Lesson 2.2, Video 1. Solving a system of equations by substitution is one of two methods that we use to get exact answers. Now it's very important to understand that when we solve by graphing, our answers are approximate. And it depends on how well you graph the line. If you didn't graph it straight, your answers will change. So graphing is an approximate answer. Substitution is a way that we can get an exact answer. So a very good way to get the exact point of intersection. Now there are steps to do this method, and the most important is to know whether or not it's ready or not. Is the system of equations ready for substitution? And the way you decide that is to say, is one equation solved for one variable? Now it says one equation, but you can actually have both equations solved for a variable. So for example, y equals 2x plus 1 and 2x plus 2y equals 3. That's a system of equations. Notice that one of the equations is solved for a variable. So that system is ready for substitution. That must be the basic step for you to go forward. Now again, like I said, you could have y equals 2x plus 1 and y equals 3x minus 3, both of them solved for a variable. That is also ready for substitution. And most students think that this is not ready because you can only have one equation solved for a variable, but both being solved for a variable is actually easier and less work. So here then, once you have an equation solved for a variable, you will plug the expression from one of the equations into the other. So in other words, I would take what y is equal to, and I would substitute it in for the y in the second equation. And we're going to see an example of what this looks like. Once you do so, you will then solve it, get the variable that is left, because you're going to go from an equation with two different variables to an equation with two of the same variables in which you can solve. And when you do that, you will get one of the two coordinates in which the two lines would intersect. And once you get that first one, you would plug it into the second equation, or actually either equation, and then find out what the second variable is, in which case now you would have both x and y known to you, which represents the point of intersection. So we're going to go through quite a few examples here to show what this would look like. And this ends Lesson 2.2, Video 1.